Welcome to this course on C programming with puzzles from in 28 minutes. Let's start with a question. How do you want to learn to drive? Do you want to sit at home, read about it, and watch somebody drive? Will it really work? I'm sure it wouldn't. Programming is very similar. I am Ranga Karnam and I have 2 decades of programming experience. I know that the most difficult part about programming is getting started. That's why we have created this course with a lot of hands-on examples. We write more than 20 programs during this course. And what's more, we use more than 100 puzzles to illustrate advanced concepts. In the first hour of this course, we learn all the concepts that are fundamental to programming. Functions, loops, variables. We try and get comfortable with these concepts with very small programs. In the second hour of the course, we really get our hands dirty. We write a number of C programs, starting with very simple ones and ending up with a little bit more complex ones like sum of digits, number of digits in a number, and also writing a structure to file and things like that. And then on, we move into the world of puzzles. We think learning is fun with puzzles, and learning advanced concepts using puzzles creates a lot of interest in students. So, what are we waiting for? Let's get started. All the code examples that we use in this tutorial are present in GitHub. They are present in a repository in 28 minutes, C tutorial for beginners. So it's in 28 minutes, C tutorial for beginners. All the code examples are present in here, and also there are links to websites which can help you install all the tools that we need as part of this tutorial. First thing, where do we run our code? What I do is I use a IDE called Eclipse, and in Eclipse I've installed CDT. But there are multiple ways you can run C programs. The simplest one among them is to use some of the online editors directly. So there's a link to it in the GitHub repository, C tutorial for beginners. If you click and open that particular thing, this is from Tutorials Point, and this is a beautiful place where you can compile and you can execute C programs. So I compiled it and I can execute it, and you can see the output shown in here. If you want to run the programs online, you can do that too. So this is where you can compile the programs and run them online. Or if you don't like this, probably you can also do a search for C online compiler and see if you can find something you like. What I am using is CDT, and you can use this link to install Eclipse and install CDT completely. So if you have access to online, I recommend you start with using an online compiler. However, for the first 15 to 20 minutes of this tutorial, I recommend you to watch the video intensely, not worrying about doing the hands-on stuff. Let's get started with our first C program. Whatever you are seeing on the screen is typically called a Hello World program. Let's not worry about what is in here right now. I'll run this program, right click, run as local C++ application. You see that there is some text printed out onto the console. So the console is where the output of the program is printed, and as you can see in the console, there is something printed out. So it says hello world in the console. So that's the program. The program was to print hello world in the console. How did that happen? So let's look at this program and make a list of questions that we have in here. We have something called stdio.h at the start. So what is stdio.h? That's the first question, right? I mean, there's something hash include stdio.h. What is stdio.h? The second thing you see is line 3. There is an int main. What is main? What is main? Then there are these open braces and close braces. So what are these open braces and close braces? And I see a printf also in here. What is printf and what is return? So these are the different questions you would get when you see your first C program. Let's try and slowly answer these questions. Welcome to this course on C programming with puzzles from in 28 minutes. Let's start with a question. How do you want to learn to drive? Do you want to sit at home, read about it, and watch somebody drive? Will it really work? I'm sure it wouldn't. Programming is very similar. I am Ranga Karnam and I have 2 decades of programming experience. I know that the most difficult part about programming is getting started. That's why we have created this course with a lot of hands-on examples. We write more than 20 programs during this course. And what's more, we use more than 100 puzzles to illustrate advanced concepts. In the first hour of this course, we learn all the concepts that are fundamental to programming: functions, loops, variables. We try and get comfortable with these concepts with very small programs. In the second hour of the course, we really get our hands dirty. We write a number of C programs, starting with very simple ones and ending up with a little bit more complex ones like sum of digits, number of digits in a number, and also writing a structure to file and things like that. And then on, we move into the world of puzzles. We think learning is fun with puzzles, and learning advanced concepts using puzzles creates a lot of interest in students. So, what are we waiting for? Let's get started.
Let's run this program once again. So I'm doing a right click run as local C++ application, and it prints hello world to the output. So we made a list of questions. What is std.h? Main, printf, what is written? Let's start with printf. Printf is a predefined function in C programming language. What do you mean by predefined function? A predefined function is something which C language already defined somewhere. Somewhere in the C language it's already defined, and it has a specific functionality. So what this particular printf function does is whatever you give to it. So printf open bracket and close bracket. So let's just take this for now. So printf is the name of the function. In any programming, usually the way you call a function is by putting an open bracket and a close bracket. So open bracket and close bracket. So this is how you would call any function in any programming language. And I want to call printf, and I want to tell printf print something to the screen. The way I tell it is by saying what needs to be printed. I want to print hello world. I use double quotes to indicate that it's a string value. So I want to print this string value hello world to the output. So double quotes indicate that whatever is inside this is a character of, is a sequence of textual characters. So there is a lot of text in here. So I'm saying printf, take whatever is inside the double quotes and put it to the output. So that's why it's printing it to the console. So let's say I put 1, 2, 3, hello world 1, 2, 3, and I run this particular program. You see that hello world 1, 2, 3 is printed in the output. Now I would do one more printf. So I'll copy this line again and put it on the next line and say hello world again. So the first thing is the first invocation. The second thing is the second invocation. So second invocation is second time I'm calling that particular function printf, and I'm passing hello world to it. What happens here? Right click, run as local C++ application. Aha, it's now printing twice, hello world 1, 2, 3 and hello world. So it's executed twice and it's running 2 times. So that's basically printf. Printf, what it does is whatever is passed to it. So I'm passing some text to it, it prints it to the console. So let's slowly look at how you can call a function. So I want to call printf, right? So how do I call printf? So printf is the name of the function. Then open bracket, close bracket. The brackets which we are using here are parentheses, round brackets. So open parenthesis and close parenthesis, followed by a semicolon. So it's basically printf, open parenthesis, closed parenthesis, semicolon. And within this, I put a double quotes, I print double quotes. And within this, I need to say what needs to be printed. I am a great guy. Let's say that's what you are, I guess. So if you want to print this, now let's run the program. I am a great guy. That's what is printed to the output. So that's basically what printf does. Printf prints something to the output. So whatever you want to print to the console, you just say printf, put it in double quotes, and there you go. That's printed to the console. So that's our first question answered. So what is printf? Let's go to second question. what is stdio.h? I said printf would print this to the console. So whatever you put it in here is printed to the console by printf. But where is the code for printf written? So where is the code for printf written? That's written in this particular file stdio.h. So this stdio.h is what is called a header. If you see, there is a specific large file in here which has a lot of code where a lot of functions which are related to C programming are defined. If I want to use printf, I need to tell C where that particular function is defined in C programming language. Since it's defined in stdio.h, I do something like hash include, and within these brackets I put in stdio.h. That's where this particular thing is defined. So that's why we put stdio.h in there. So that's our second question answered. Now let's go to the next question, and I guess that's the main question as well. What is main? Main is a very special function in C programming language. Actually, it's special in C++ and Java as well. And what is the speciality of main? The speciality of the main function is that whenever you run a program, that's the first function that would be called. So let's take an example. What I'll do is I'll copy the main function. Okay, I'm copying the main function and putting it out here. Just to differentiate the fact that this is something else, I'll, instead of printf I am a great guy, I'll say I'm saying I will not be executed. So, or I will not be run. And I'll change the name of this function from main to print something. I'll just say print something. I just copied the code of main. So this is the code of main. I copied it and I changed the function name to print something. I want to see if this line of code is executed and whether this text would appear on the console. Let's run this program. You see that the only thing which is printed is I am a great guy. I will not be executed is not printed to the console. Why is it not printed? I mean, if you see the code in here, it's present, but why is it not executed? The reason it's not executed is because every time execution in any C program starts with main and it ends with main. So the 11th line is which line which is first executed. So when you run this program, what happens is the compiler starts, the execution starts at line 11. So line 11 is executed, printf, I am a great guy. That's the first thing which is executed. The next line is return 0. We will discuss what is return a little later. But so this is printf, return 0 and end. So that's it. That's all that the C program does. It does not do anything which is not defined in main. That's the reason why main is a special function in C programming language. And the start and end of the program execution is with main. And that is the reason why we lot of times start with writing a main function. So to summarize, main is the first function which is executed by C programming language, and the other functions, if you want to call them, you have to call them from main function. We will learn how to call other functions from main in the next section. We ran this program and we saw that only main is executed. Print something is not executed at all. Now let's look at what is a function. So we said main is a function, right? So what does it mean? What does really a function mean? A function is a set of statements. In any programming language, most of them actually, the statements are separated by semicolons. So if you look at this printf, we are calling printf open parenthesis close parenthesis followed by a semicolon. Return 0 followed by a semicolon. So this is a set of statements. Function is nothing but a set of statements and enclosed within open brace and a closed brace. So a function generally does something. So here, if we look at the print something method, it is printing something to the output, and it's returning 0. So this open brace and the close brace signify the start and end of a function. So a function starts with open brace and ends with a close brace. The return value from main typically signifies what is the status of the execution of a particular program. Let's say I'm trying to read something from the database and I was not able to connect to the database. Then I would probably return -1 back to say that the program failed in executing. If I'm able to connect to the database and I'm able to execute properly, then I will return 0 to say that I am successful. What are void functions? How do I say a function is void function? By instead of int, I'm putting void and I'm removing the return statement. A void function is something which does not return anything back. So that's simple. A void function does not return anything back. So what we wanted to do in here is we wanted to run the print something method also. So what we want to do is we want in main, I want to be able to run print something method as well. So how do I do that? What I would do is add a new statement to the main method. What is that? I have to say print something open parenthesis close parenthesis. It is not having any parameters defined in here. No values needs to be passed to it. We will discuss about parameters later. So now I'm calling print something. The way I'm calling it is open parenthesis close parenthesis followed by a semicolon. This is a statement. Any statement should be followed by a semicolon. So now let's run this program. Aha! What do you see in here? I'm a great guy. I will not be executed. So what is happening now is first the execution is coming to line 10 because main function is the first function which is executed. So execution comes here, then number 11 print something is called. So it goes to print something. The first line in print something is I will not be executed, and once print something completes execution, it returns back and the program completes execution after the return 0 is executed. And so I see in the output, I am a great guy, I will not be executed. So that's how you call a function from another function. We actually already called printf. Printf is another function which was defined in stdio.h. This is a custom function. I mean, this is defined by us. This is defined by a programmer. So this is how we would call a custom function from main or any other function. We are printing I am great guy and I will not be executed on the same line. Let's understand why this is happening in this way and what we can do to get them printing on the next lines next. The thing which I want to do is after an I am a great guy, I would want to print something called a new line character. Only then I will not be executed would be printed on the next line. So what I would need to be able to say here is I'm a great guy followed by new line character. If I am able to do this, then it would get printed on the next line. This new line character is something which you will not be able to type on a keyboard. That's why C uses special characters to indicate new line characters. That's /n. So a slash followed by n, this is called a new line character in C programming language. When I run this particular thing, you would see the thing being printed on the next line. There is one more special character. Actually, there are a lot more special characters. One more thing that we would see is /t. The /t stands for a tab. So let's see what happens when I run this program. Okay, you can see there is a tab space between I'm a and the great guy. So in here there is a tab space that is coming in because I'm saying a /t. Usually the slash followed by some character indicates that it's a special character. We will discuss a lot more about these things in a future section. For now, let's just say /n and run this program. There you go. I'm a great guy. I will not be executed is printed on the next line. Let's now shift to another important concept in programming, which is variables. What is a variable? Let's start with defining one. The way you define a variable is int and the name of the variable score. This is how you define a variable in C programming language. Actually, this is the way you declare variables in C, C++, and Java, and a lot of other programming languages as well. It's the type of the variable. It's basically, when I look at this particular thing, it's type of the variable followed by name of the variable and semicolon. So this is how you define variable. So type of the variable and the name. The type of the variable indicates what kind of value that you would want to store in a variable. That's, I want to store a number, and that's what int represents. Int is a short form for integer. I want to store an integer value. An integer value is something which is negative, -12, or it can be positive, which is 12 or +12, or it can be 0. So these kind of values you would want to store in the score variable. What is a variable? The variable is something which can change its value over a course of a program. When I say something is a variable, it means score is equal to 1 here, and at a later point score might be 2, and at a later point score might be 3. And this is what is a variable. A variable is something whose value can change over a period of course of execution of a program. At one point the value of score is 1, at another point the value of score is 2, at another point the value of score is 3. Whatever operator we are using, the is equal to in here, is called an assignment operator. This is called an assignment operator. An assignment operator is one of the most important things in programming. Even though it looks like is equal to, this is not score is equal to 1. The way you can read it is score is assigned a value 1. That's the best way to read this. Or 1 is assigned to score. Do not read as if its score is equal to 1. It does not mean these two are equal. Here, the is equal to which is used in here is called an assignment operator. So, two things we were discussing. One is variable. Variable is something whose value can change. So, over a period of program, the value of this particular score variable will change. First it is 1, next 2, next 3. The best way to think about a variable is like some kind of a box. So the way I think about variable is some kind of a box, this kind. So variable is a box. In this box you can have a specific type of value. What type did we declare for score? When we talk about score in here, score is a integer variable. Score is an integer variable, and when this particular score is assigned a value 1, the value inside the score box is 1. When I put 2 in the score box, the value becomes 2. When I put 3, the value is changed to 3. So that's basically how you can look at a variable. A variable is something which can house some value, but it can only store one value. What does basically mean is once score is 1, it becomes 1. Once I put a value of 2, it loses the earlier value of 1, it becomes 2. So the fact that score has a value of 1, it doesn't matter anymore. Right now score has a value 2. And next, when score is updated to 3, it is changed to 3. So a variable can store one value at a point in time. Let's go back and try something tricky. I want to print what value is present in the score using printf. So I want to see what is the value in score now using printf. How do I do that? The way I do that is by using, I want to print the value of score, right? Score colon, this is what I want to print, and I would want to print the value of whatever I want, whatever is in score in here. The way you can do that is by passing score value. So I have to put a comma, score. So that's first thing. Let's run this program. It is printing score value. So it's printing value and not the actual value of score. How do I tell printf to print the value of score? I would need to tell printf what type of value it is. So the way I would need to say that is percentage %d. So d in printf stands for integer. I have to say percentage followed by something indicating the type. D indicates the fact that score is an integer. So I want to print an integer value. The way I do that is percentage followed by something indicating the type. The type is integer. Integer is represented in printf by d. So percentage %d. Now let's run this program. Okay, that's perfect. So score, and it's printing a value of this. Aha, where did the program get its value from? This particular value which is present here is called a garbage value. Since we did not assign any value to score, C assigned some garbage value to it. So if you don't assign something, be prepared to get some garbage from C language. Next, let's look at how to assign some value to a variable. How can we assign a value to a variable? The way you can assign a value to a variable is by using an assignment operator. That's basically what we would try and understand. The typical structure of an assignment operator is something of this kind. So it's something of the kind where you have a variable is equal to value. This is how the assignment operator is. What happens then is whatever is in value gets copied into the variable. So right now we looked at this particular variable and we saw that it was printing a value like this. So this was the value which was present in the score when we ran the program last time. So when the value is created, it has some dummy value. So when score is created, it has a default value or a garbage value, dummy value, whichever way you want to call it. So how do I change the value in it? As we discussed earlier, the syntax is variable is equal to value. So I want to put score. I want to put a value 10 in it. So I put in 10 and followed by ending the statement, which is semicolon. So that's how I would put a value in there. The way you can read the assignment operator is a value of 10 is assigned to score. So what would happen at the end of this line is that this value which is there would be replaced by 10. So the value in score becomes 10. So the value of score at the end of this statement will be 10. Let's run this program and see what happens. There you go. You see that this printf is printing score %d and score has a value of 10. Let's say I assign a value 20 on the next line. Once the program starts running, here score has a garbage value. Program goes to the next line, score is assigned a value 10. So here the value would be 10. Next, it goes here, the value of score is 20. So instead of 10, it becomes 20. And later, we are printing that particular score. So I expect 20 to be printed. There you go. You see that the score was 20. So if I want to print the score here on line 15 now, I have to put a printf in there. So now I'm printing what is the value of score in here. The value of score at this particular point will be 10. So first 10 will be printed. I'll add a new line character so that we print it on the next line. So first score 10 is printed and then score 20 is printed. Let's just check it out. First this line gets executed, this score. When this line is executed, the value is 10. When this line is executed, the value is 20, and that is exactly what is printed out to the console. So this is how you assign values using assignment operator to a particular variable. Let's now have two different variables. So let's have int score and int score 2. Let's call score as score 1. So we have two variables, score 1 and score 2. So how many variables do we have? Score 1 and score 2. And now we would want to play around with them and do different things with them. So let's start with assigning an initial value to them. Score 1 is equal to 5. Score 2 is equal to 15. So score 1 has a value 5. Score 2 has a value 15. I am printing here score 1 is score 1 and score 2 is score 2. Now, what would be the value of this program? It's easy to guess, right? It would print the value of score 1 and score. There you go. So it prints the value of score 1 and score 2 to the output. Now, I would want to add both the score and I would want to put it in a different variable called sum. So I'm creating a new variable, int sum. In sum, I would want to print the values of score 1. I would want to put a sum of score 1 and score 2. How do I do that? The way I do that is sum is equal to, what is the value that I would want to put? Score 1 plus score 2. This is how I would do the sum, and this is how I can print the sum value as well. Sum. Let's run this program and see what it prints. There you go. It prints score 1 5, score 2 15, sum 20 on the same line because we didn't add a new line in here. So I'll add a new line and let's run this again. Now it prints score 1 is 5, score 2 is 15, sum is 20. We are printing score 1, score 2 and sum on 3 different lines. I would want to print them on the same line. How do I do that? The way I can print that is by using a printf where I can have multiple arguments passed in. So what I would want to do is score 1, I would want to print the value of score 1. So I'll put %d. Score 2, again I want to print the value of score 2, and next I want to print the value of sum and %d. And I have to pass the values in the same order. So here the first %d, what do I want to print? Score 1. So first I have to print score 1. I have to put a comma and pass in the next argument as score 2 and next one as sum. This is the way I can print all of them on the same line. So if you look at the code, it's very simple. So basically I'm putting %d wherever I want to print the value, and I'm passing those values in the same order. So %d, first %d is score 1, second %d is score 2, the last one is sum. So that's the order I'm passing them in. Let's run this program. So there you go. Score 1 is 5, score 2 is 15, sum is 20. So there you go. That's a very simple program to understand how assignment works and how you can find the sum of two variables. Let's now try and get an in-depth understanding of the assignment operator. I have a simple program on your screen right now. It's int main, int I is equal to 5. So instead of saying int I and then at a later point saying I is equal to 5, I can do a simplified assignment at the time of creation of a variable by saying int I is equal to 5. So int j is equal to 6. I could have also defined variables like this: I is equal to 5, comma j is equal to 6. That is allowed in C programming language. If I run this program, it prints the value of I and j. But I prefer the declarations like this. I really prefer separate declarations for each variable, but it's a matter of personal choice. If you like the other syntax, you can go ahead and use it. So int I is equal to 5, j is equal to 10, and I'm printing the values of I and j. What I want to do here is I would want to be able to swap the values of I and j. So I has a value of 5 and j has a value of 10. I would want to put a value of 10 in I and 5 in j. So how do I swap the values of I and j? Swapping means exchange of values. So if I have something and my friend has something else, swapping means I take what my friend has and I give my friend what I had earlier. So here swapping of variables means I has a value of 5, j has a value of 10, so I gets 10 and j gets 5. That's basically what swapping means. So the primitive program which typically starting programmers write is I is equal to j, j is equal to I, and they expect it to work. Would this work? Nope, both of them have a value of 10. Why do these values have a value of 10? Think about it. Let's look at it in detail. Line 13, execution starts, I has a value 5. Line 14, j has a value 10. So that's very good. Now, what happens? Line 16, I is equal to j. It doesn't mean I and j are equal, but it means the value of j is copied into I. Value of j is taken and put into I. So what is the value of j? It's 10. So this value is taken and it's put into I. I is equal to j. The value of j is put into I. Value of j is 10. So I becomes 10 as well. Now j is equal to I. What is the value in I now? I had earlier had a value of 5, but now it has a value of 10. So this value is taken and put back in j. So what would be the value when it's printed in here? You would see 10 and 10 being printed. Understanding this particular thing is one of the most important challenges for a starting programmer. Once you understand this concept very well, then you can understand a lot of things in programming very easily. So what is happening in here? I is equal to j. I is equal to j doesn't mean I and j are equal. It means I take the value of j and I put it in I. When I started running this program, let's do it again. So I has a value of 5 first, j has a value of 10, so j has a value of 10. When I say I is equal to j, what happens is the value of j is put in I. The value of j is 10, 10 is put into I. So 10 is put into I. So the 5 is lost. So nowhere in memory the value of 5 would be stored thereafter. So now the code execution moves to the next line. J is equal to I. Now I has a value of 10. So the 10 would be put into j. J is equal to I. So I value is copied into j. 10. This is copied into j. No change. So now I and j both have a value of 10, and that is what is printed into the console. Think about how I can really swap two variables. Don't worry if you are not able to get this right, because this is one of the toughest challenges for a starting programmer. The way we do the swapping of variables is by creating another variable called k. So we use a temporary variable called k. So what I would do is actually I would use k to store the value of I. So the initial value of I would store it into k, and at this point I gets overridden with the value of j. So what would happen? K is equal to I. At this point, what would be the value in k? K at this point will have a value of I, which is 5, right? So k is equal to I value is copied into k. So k will have a value of 5. I will have a value of 5. J would have a value of 10. Now, the next statement, I is equal to j. So what would happen? K, I'm not changing. The value of j is copied into I. So the value of j is 10. 10 is copied into I. So I becomes 10. I'm not changing the value of j. So j remains 10. Next, I'm saying j is equal to I. So what happens? K, no change in the value. I'm not changing the value also. What I'm doing is copying the value of I into j. So what is the value of I? I is 10. 10 is copied into j. J is equal to 10. So this does not work. This does not swap the values because I has a value of 10 and j has a value of 10. For it to work, what I should do is I need to copy the value of k. K has the value of 5, which is the earlier value of I. So what I would need to do is j is equal to k. So if I do j is equal to k after this line, so k will have a value of 5. I am not changing it. So I will still have the value of 10. And j is equal to k. So j will get a value of k, which is 5. So now the value of I and j are swapped. Earlier I had a value of 5, j had a value of 10. Now I has a value of 10 and j has a value of 5. And when I run this program now, it would swap the values, and okay, I is 10 and j is 5, and we were able to swap the values of I and j. Very big success. I think if you are able to understand how this swap program is working, then you can give yourself a high five, because understanding the swap program is, for me, is one of the fundamental stepping stones of becoming a programmer. We will discuss about another variable type called float. Before that, we'll look at a small example. What I have on your screen is two variables, int I is equal to 1, j is equal to 2. And I have another variable int average. And I'm saying average is equal to I plus j divided by 2. So the way I'm doing I plus j is I'm putting it in brackets so that I'm giving this operator. So I plus j gets executed and divided by slash in C and by 2. So I plus j by 2. So I has a value of 1, j has a value of 2. 1 plus 2, that's 3. 3 divided by 2 would be 1.5. So would 1.5 be printed as average in this particular program? Right click, run as local application. Nope. I see a value 1 being printed. The reason why 1 is printed is because average is an integer and integer value cannot store decimal values. And that's why we need floating point variables. I can change now this to float and I would divide by 2.0. So I'm making float as float average float and I'm changing this to 2.0. So floating point numbers can store decimal values. So it can store values like 1.5, 2.5 and whatever else. Earlier we saw that when I'm printing a value, D means integer. Similarly, F means float. So F stands for floating point value. So F, when I use in printf, stands for floating point value. So if I want to print a floating point value, I have to print percentage %f and average. So I'll say average percentage %f comma average, and let's run this program and see what happens. There you go. It's printing 1.5, a few zeros afterwards. We'll discuss later why those are printed, but it's printing the value of average of 1 and 2. So let's change this to 1 and 7 or 1 and 9 or 1 and 10 actually. So 1 and 10, 5.5 should be the average, just to see if it's working fine. There you go. 5.5 is printed to the output and that's perfect. The other kind of variables which are present in C are characters. So characters are represented by char and ch is equal to, typically characters are represented between single quotes. So A. So A is a character and I'm using C within single quotes to represent the value. So ch is equal to A. And the way you would print a character is by doing percentage %C. C is used to print a character. Let's see what happens. So it prints the value ch A. A is the value which we wanted to print in here. Characters can store any character that you can type on the keyboard. Typically, we store ASCII values inside the character. So if I want to store the value of A, I can also store value 95. So 95 is the ASCII value for A, I guess. I don't know actually. Actually, it's 97. So let's try with 97. So 97 is the ASCII value of A, and when I store 97 into a character, what is printed is that particular character itself. So this is how characters are represented. Characters are internally represented as integers, but not as big as integers. They are smaller than integers, but the integer value of the character, the ASCII value of the character, is what is used to store the characters in C programming language. And that's why when I stored 97, it's storing small a. When I store 65, you can try and guess. Yep, it's capital A. Now let's switch to functions. We discussed a little bit of functions earlier, but let's get a deeper understanding of functions now. What you're seeing on the screen is a simple program. Int main, it's printing welcome to in 28 minutes thrice. When I run the program, this is the output I get. Welcome to in 28 minutes. It's printing on the same line. I don't like this. /n, /n, /n for the third time. Runs. Okay, this is good. Now I missed .com. Let's add .com everywhere. Okay. Yeah, please do save. Okay, that works. That's cool. But what you would have seen is I have to make 3 changes for any change that I would want to do, even though I'm doing the same thing 3 times. And this is where the functions come into picture. I kind of can create a function which can do this, and then I can call the same function thrice. Then I would not need to modify the same thing again and again. And that's what we would be doing now. So the way you can create a function is something of this kind. First thing is return type of the function. Return type of the function, name of the function. So name of the function, first is return type, name of the function, open bracket, close bracket. Actually, there are something called arguments we will talk about later. There are no arguments in our first example, so I'll remove that. Then the next thing which would come in is the open brace to indicate start of the method and close brace to indicate the end of the particular method. And in between is what is called body of the method. The body of the main method contains 3 statements: printf, printf, printf. Whenever we create a function, we would need to have the body also in there. So let's create a small function. So I'll say return type, I don't want to return anything, void. So void means I don't want to return anything. Name of the function is welcome. So I want to call this function as welcome. Open parenthesis, close parenthesis, open brace, close brace, and between that I want to print welcome to in 28 minutes. So that's it. That's a new function. It's as simple as this. Now here I don't want to use this particular thing. So now I don't need to do all this stuff. So whenever I want to do this, I can say welcome, and that's it. The function is called. This is called invocation of a function. So whatever we are doing is here is calling a function or invocation of a function. Whatever we are doing in here is we are defining a function. So we are giving a definition for this particular function, and whatever we are doing in here is calling or invoking a function. The first line of the function is also called the signature or the declaration. So declaration or signature. The first line is called declaration, and the complete this thing is called the definition of the method. So let's make it very simple. This is declaration. Whatever is highlighted is the definition of this particular method, and whatever we are doing is called invocation. One more time, this is the declaration. Declaration is what is the return type, what is the name of the function, what are the arguments. That is declaration. Definition is declaration and also the body of the method. So definition of a method contains the body of the method as well. The invocation is where the method is called. So now I'll call welcome, welcome again, and now I'll run this program and you would see, there you go. You see welcome to in28minutes.com is printed thrice. If I want to change something, I don't like a capital I really like the small I thing in here. I make one change and you would see the change reflected everywhere else. That's the beauty of using functions. The reason why we prefer using a lot of functions in programming is because with functions, they avoid duplication of the same logic. Earlier, I had this present 3 times in my code. Now it's present only once in my code. Thereby, I prevented the duplication, and also it improves the maintainability. So whenever I want to change something, I don't want to call welcome to in 28 minutes, or I want to change this from hi from in28minutes.com. All that I do is change one place, and wherever it's called, the change from that particular function is reflected in all those places. That's the beauty of. Now let's switch over and discuss a little bit about conditionals. Earlier we looked at calling the welcome method thrice and we created a function for it, and here it is. So this is the welcome method which prints the welcome to in28minutes.com, and we were calling it thrice earlier. What I've done is I've removed the calling it thrice and I've added in a new function called subscribe. So I've added in a new function called subscribe and I'm calling the subscribe in here. So what happens now? It prints both of them to the output. Welcome and subscribe. But does everybody subscribe? Actually not. Somebody will subscribe only if they like it. So I want to create a variable like. So int like. So like, I would want to give it a value 1. So if somebody likes it, I would want to do a subscribe. That's where the if condition comes in. Only if somebody likes it, we will subscribe. In C programming, this any value which is other than 0 in like is treated as true. So this particular if condition like will result in a true. So this will be a true if like has non-zero value. So if like has a non-zero value, this will be true, and only then this line is executed. So line 19 which is in here is executed only if like is true. So let's run this. I have a value of 1 in like. So let's see what happens. Will subscribe get executed? So you see welcome and subscribe, both of them are printed. So when like has a value of 1, both of them are executed because 1 is a non-zero value. But when like has a value of 0, what would happen? Welcome to in 28 minutes, but this particular thing is not executed at all. This is a conditional statement. So the statement in the conditional is only executed when this condition is true. When like has a value of 0, this condition is false, and that's when this particular statement is not executed at all. One of the good programming practices is to have open braces and close braces around blocks and put the code inside them. So now if you look at it, this is very similar to the code that we had earlier, but this is much readable code, and in here I can add more statements if I want. So if block can contain any number of statements that you would want. So I would want to call subscribe again, I can do that. So now you would see that so only first statement is executed, but nothing in the if is executed. So nothing in the highlighted part is executed because like has a value of 0. But if like had a value of 1, there you go. So both these statements are executed. Subscribe is called twice, so it's executed twice, and everything is printed in here. Now if let's say it's somebody does not like something, and only in the other condition I want to do something, that's where the else statements comes into picture. I can do else printf. I'm saying please tell us what we can do to improve, and so this is where the if else statement comes into picture. So if this condition is true, then this line is executed. If this is not true, then this line is executed, and this line will not be executed at all. So if like has a value of 1, what happens is the subscribe gets executed. Let's run. So welcome, subscribe. The next thing doesn't get executed. If like has a value of 0, what would happen? Welcome is executed, and the printf in here is executed. So it says please tell us what we can do to improve. So that's basically the if else statement. The if else statement is usually used when you have something to do if the condition is true and something else to do in a condition is false. So this is if else. What we want to write now is a simple program to print how many runs were scored of a particular ball in a cricket match. In a cricket match, if 1 run is scored, it's called a single. If 2 runs are scored, it's called a double. If 3 is scored, it's called a triple. And if 4 is done, it's called a boundary. And for 6, it's called a sixer. So let's just think this is the way we want our score program to print. So when I pass in 1, it should print single. When I pass in 2, it should print double, 3 triple, 4 boundary, and 6 sixers. How do we write a program to do that? The way we can do that is using the if condition. So if score has a value of 1, so if score is equal to 1, actually In C, to compare, we have to use double is equal to. So score is equal to 1. This condition will be true if score has a value of 1. What should I want to do when score is 1? I want to printf. When it's 1, it's single. So that's what I want to print. Now, else I want to check if it's 2. How do I do that? I can do something like else if score is equal to 2. I want to print, what do I want to print? Double. Else, for now, I would printf something else. This is called a nested if else structure. So if score is equal to 1, do this. If score is equal to else, if score is equal to 2, do this. Else, do this. So you can have any number of these kind of else if. So if I want to do else if, I can do if score is equal to 3 triple. I can do that as well. So for now, I'll leave it at this and I'll run this program now. So score has a value of 1. So what happens is this line is executed and none of the next lines are executed. So it will only print single. It prints an output single. If score had a value of 2, what would happen? Let's see. It prints double. And if score had a value of 3, it would have printed something else. This is a simple example of a nested if else. So we looked at if, else if, and nested if else's now.
Until now, we saw how to use an if, else if, and nested else if. In this section, let's look at how to use a switch statement. So I want to do the same functionality. I mean, whatever is in here, I would want to do the same thing, but now I would want to use a switch statement to do this. How do we do that? That's basically what we are going to discuss now. The syntax of the switch statement is very simple. It's switch. What do you want to switch on? What is the variable that you would want to switch on? So I would want to switch on score. So that's the start. So switch, open brace, close brace. Switch on a variable and open brace, close brace. And I can say what I want to do when score is 1 is to print single. So the way switch works is I can say case 1. What happens is case 1 is executed when score has a value 1. So when score has a value 1, what is executed? Case 1. So let's take the code from here and put it in here. Okay, next I would need to put the next case. The next case we have below is case 2, right? So I take this and put it in here. Aha, that's perfect. And the last one is else. How do I say else in a switch? So when score is 1, print this. Score is 2, print this. Else. How do I do that? And switch has a solution for it. That's called a default. So default is when it does not match any of the cases. So it does not match case 1, it does not match case 2. Then go ahead and do this. Let's remove this out. I'll remove the if statement below. And you see the complete thing that we wrote for this particular program in here. So what we are doing is switch score between the braces. So this is the open brace, close brace. Within that, I'm writing all the cases. When score is 1, this line is executed. When score is 2, this line is executed. And default, if it does not match any of the cases, let's say I had 100 different cases in here and it didn't match them, then the code in default is executed. There are few tricks and tips down here with switch statement. We'll discuss them in detail now. Let's put a value of 1 in score. So I'm putting a value of 1 in score and running this program. Let's see what output is printed. This is not something which I expected. So it's printing single, double, something else. Okay, that's where the switch is a little different. The thing about switch is once a case matches, so this case matches, so case 1 matches, so it would continue to execute everything in the switch. So what it does is once a case matches, it would execute everything else after that. So Case 1, it's printing single, double, something else. Let's put a value of 2. Try and guess what would be the output. Case 2, it prints double and something else, because when it's 2, case 2, this matches, so it executes all the lines after that. So double and something else. Aha. What if it's 3? Aha. It prints only this line because there is nothing else after that, so it only executes this. In case 1, I don't want to execute everything after that. So I don't want to execute case 1 default when case 1 matches. When it's 1, score is 1, then I just want to print single and forget about it. I don't want the next statements to be executed. How do I tell a switch statement that? That's where the break statement comes in. The break statement tells switch, so when you see me, go out of the switch. So what happens? Case 1 matches, it prints this line, and then it comes and executes line 13, which is a break. Aha, break. So I have to go out of the switch. So it goes out of the switch and starts executing whatever code is there after the switch statement. That's how you do a break. So now I'm adding a break after single. So let's see what happens. So now if I have score value 1, what would be printed? Let's see if only single is printed properly. Aha, there you go. This works. But what if it's 2? Think about it. Do we have a break after case 2? What would happen? So it's double and something else. Both of them are printed because I don't really have a break after a case 2 yet. So now I go in and add the break in, and now if I run the program, now only double is printed. So nothing else. So something else is not printed. So actually, good coding practices suggest even after default add in a break. There is no sense in adding a break in here, but just in case somebody comes in, actually in switch it's allowed to have a case after the default. So the order of default doesn't necessarily have to be the last one. So if somebody comes in quickly and adds in a case 4 and says printf boundary and adds in a break, let's say, if this break was not there after default, what would happen? When it's default, it would print something else and boundary, both of them together. So it's always a good programming practice to have a break even after the last case statement. So let's go ahead and now run this program. Let's have a value of 4 in here just to illustrate the whole thing. So when it's 4, obviously it will only print one line which says boundary. When it's anything else, let's say 6, aha, something else. So that's where this line comes into picture. So default comes into picture, it prints something else, and there's a break, so it does not execute the code after this. So that's your switch statement. A switch statement is one of the, I think switch statement is one of the statements which makes the code more clearer than a nested if-else statement. But obviously you can't use a switch statement everywhere. You can use a nested if-else. If you are doing simple matching on a value, so score is equal to 6, then you can use a switch. If let's say you had a conditions that you are checking in an if-else statement, then obviously you have to go for a if-else, and switch does not have something matching that. Let's now learn about an important concept in programming called arrays. It's A-R-R-A-Y-S, arrays. Before going into arrays, let's understand why we need arrays. What if we don't have arrays? What would happen? Let's see an example right now. What we have in here is 3 scores of the top 3 batsmen in a team. So I'm storing them in score 1 is 6, score 2 is 15, score 3 is equal to 145. So the top 3 batsmen in the team had scored these runs. And I want to find out how many of the top 3 batsmen in the team scored centuries. So basically I want to find out how many of them are scores of 100 and above. So if score 1 is 6, score 2 is 15, score 3 is 145, only score 3 is a century because it's greater than or equal to 100. So that's exactly what I want to find out. I've written a small program to do that. The program looks something of this kind. So I have a variable called count which has a value of 0. So initially I'm having value of 0 and I'm checking if score 1 is greater than 99, or it's the same as saying greater than or equal to 100. So if it's greater than 99 or greater than equal to 100, it's really the same because score is an integer, score 1 is an integer variable. So if score 1 is greater than or equal to 100 or it's greater than 99, then I'm incrementing the count. So let's say score 1 had a value of 150, the count would be incremented. Score 1 has a value of 6, so this value will not be incremented, so it will remain 0. It comes here, I'm doing the same check on score 2, 99. Score 3 again is 99. I mean score 2, score 3 we do the same check and increment the count again, and at the end we print number of centuries. So if I run this program now, what's the output? How many centuries? Score 3 is the only one which is a century, so it prints as 1. Let's say I had 106 in here. Then 2 of the 3 batsmen had scored a century, and so what would be the output? Yep, you're right. Its number of centuries is 2. So that's basically the thing. So now you have number of centuries is 2. Now let's say instead of the top 3 batsmen, I want to do this analysis for top 4 batsmen. So I would need to add in another variable. Score 4 is equal to, let's say, 23. I want to include the score 4 also in. I have to do the same condition, repeat the same code again. Score 4 is greater than 99, count is equal to count plus 1, and then I'm ready to run the program. So now run as local application. Okay, now I'm ready for score 4. Imagine if I have to keep adding keep adding logic for each of the variables separately. A cricket team usually has 11 members. So if I have 11 different variables to store the scores of individual batsmen, then it makes it very difficult. That's where the concepts of arrays comes into picture, and also the concept of loops. Now we'll use these two things to solve this particular problem. So let's get started with arrays. Instead of doing something of this kind, score 1 is equal to 106, score 2 is equal to 15, score 3 is equal to 145, and score 4 is equal to 23, what we can do is I can create an array. The syntax for array is something of this kind. Int, what does it contain? And I want to have scores. The name of the variable, name of the array variable is scores. The way you differentiate between an array and a normal variable is by introducing these brackets, square brackets. With this square, like if you put a square bracket, open square bracket and a closed square bracket, and say is equal to, and put in all the scores that you would want to put. So I would want to have 106, comma 15, comma 145, comma 20. This is what is called an array. Before we go into this particular logic in here, let's spend some time understanding the different things about an array. So I have created an array. If you look at it, the way we created it is scores, open square bracket, close square bracket is equal to, within braces, I put in the different values I would want to store in an array. The values which I want to store in this particular array are 106, 15, 145, and 23. Now that we learned about this course array, how to create an array, let's focus on learning a few more things about the array. First thing we would want to learn is how do we assign, or how to read values from an array. I have a value 15 in here. How do I read that? How do I get that value out? And the second one is how to set values into an array. And the third one, which we want to understand about an array, is how to find length of the array. So here there are 4 elements in this particular array, right? So how do I find the length of an array? That's the next question we would want to handle. Subsequent to this, I want to understand what is the default value in an array. So if I don't assign any values to an array, what would be the default value that is assigned to a particular thing? Last thing which we want to understand is, what if I try to read what if I try to read, or I try to bite more than I can chew? What do I mean? What I really mean is, here there are 4 elements. What will happen if I try to read the 10th element of this array? What value will it? Those are the answers. Those are the questions we'll try to answer now. So first question is how to read values from an array. How do I read the fact that I want to get the value 106 out of this or 145 out of this. How do I read it? First thing you need to understand is indexing. A lot of programming languages use something called a zero indexing. So that basically means the first element of the array is index 0. The second element is index 1. The third element is index 2. So basically the index starts with 0 and goes in an increasing order. Let's say I want to read 15. I want to print the value of 15. So printf %d, comma, what should be the value in here? That's the question. Where do I want to read the value from? I want to read the value from scores. And anytime you talk about an array, you can always think about square brackets. So I use the square brackets. Within the square brackets, what should be the value? The value should be the value of the index. So if I want to read 15, the value of the index is 1. So I put scores of 1. Let's run this program and see if it works fine. There you go. There you see the value 15. So now you can think and tell me how I can read a value 23. Yep, you're right. It's 3. 23. And the first element of the array, 106, I can read it by using this. Aha, 106. There you go. So that's how you read values from an array. Now, I want to change the value of a specific thing in the array. How do I do that? The way you do that in C is exactly the same. So if let's say I want to set the value for the first element, scores of 0, I want to change it from 106 to let's say there's a small modification in this code. They actually counted 2 runs less, so the score became 108. So I want to set the value scores of 0 as 108. Let's see what would happen. Now I'll comment out this just because we know how to print the value once. We'll try and print the value in here. That's what you see in the output. So that's exactly what I wanted to set the value of the first element to be. So now we have learned how to set the value and how to read values from an array. Next question is, how do you find length? There are 4 elements in this particular array. How do I find the length? Actually, the bad thing about this answer is actually there is no direct way of finding the length of the array. I mean, there are kind of tricky alternatives. Probably those would be little too too complex for you at this point in time. So let's not discuss that. Let's just assume that whenever I want to store the length of the array, I store it in a variable. So I'll also probably say scores length. For now, store the value statically. I would not really dynamically determine the length of the array, but for now I would kind of store it in a static way. So that's how to find the length of the array. The next question is what is the default value of the array? One of the things that you can do when you declare an array is also tell the size of the array. So here we said scores and we just had an empty square brackets in here. That means we are saying the size of the array is however big the number of elements in here are. So there are 4 elements in here, so the size of this array is 4. But I want to have 10 elements in the array. So I want to have 10 elements in this array, then I can put 10 in here. So there would be 10 elements, but I'm assigning values only for 4 elements. What would be the value of the 4th element or the 5th element? So what is the default value? If I don't assign a value, what would be the value which would be assigned by C? Let's see that by using the scores of, let's print scores of 5. I want to find the 6th element in the array. Now, what happens? It's 0. So default value, if you declare the array as as longer than how many values you initialized. Here I'm initializing 4 values, whereas I'm saying the size of the array is 10. So the rest of the 6 values would be assigned a value of 0. But if you go further down, so what if I try to bite more than I can chew? That's basically I have a 10 element array here, but I want to print the 11th element or I want to print the 12th element. How do I do that? By saying scores of 11. So I'll just comment this out so that now what would it's printing some garbage value. So what if I try to bite more than I chew? This is what will happen. I'll get some default value, garbage value, not default, some garbage value which is present somewhere, which is already present in that particular location. So we have not assigned the value, but we would get some garbage value which is already present in that location. So what we looked at until now is how to read value from an array. So if I want to read the third element in the array, I use index 2. So I'll say scores of 2. And similarly, I can set the value as scores of 2 is equal to 15. And we saw how I'm saying this is 10 element array, but I'm initializing only 4 values. So all the rest of the 6 elements will have a default value of 0. But if you try to read a 12th element or a 13th element in a 10 element array, then you would get some garbage value. Those are the important things about an array. We will discuss more about arrays subsequently. Now that we looked at the basics of the array, let's focus on loops. So in this particular section, we will look at how you can use a for loop, a while loop, and a do while loop to loop through the values and print the values of this particular array. So that's the focus of this particular section. What we want to do is we will want to loop around this particular array and print all the values which are present in this particular array. How do we do that? Let's start with the for loop. The syntax of for loop looks complex, but it's actually quite simple. So I'll for now put everything on separate lines just to make everything very clear. So usually we don't put this on separate lines, we have it on single line. What we have in a for loop is the first statement. We typically in a for loop you would have 3 statements. So you'd have statement 1, statement 2 and statement 3 in here. The first part of the for loop is called initialization. The second part is called the condition or the check that you want to do. The third part is called the increment part. Until now we have seen how assignment operator is used. I is equal to I plus 1 would kind of take the value of I plus 1. So I is equal to I plus 1, what happens? I plus 1 gets calculated and stored into I. So if I has a value of 5, I is equal to I plus 1. After this statement, I will have a value of 6 because 5 plus 1 is 6. 6 would be stored back into I. There is a shortcut for this particular thing, which is I plus plus would do something very similar. Minor difference is there, but effectively after the execution of this statement, the value of I would be incremented. Whether you do plus plus I or I plus plus, the value of I after the statement would remain incremented. There is a little bit of difference between plus plus I and I plus plus, which we'll talk about in subsequent sections. But for now, you can kind of think I plus plus is very similar to I is equal to I plus 1. It's an increment. What I do in a for is I can say int I is equal to 0. So that's the initialization, right? We want to put it down. So int I is equal to 0. So where do we want to start from? We want to start from 0 and we want to go up to 3. So in our loop, we would want to start with 0, first print 0th element, then print first element, then print the element at index 1, that's second element, then print the element at index 2, that's the third element, and then print the last element which is at index 3. So where do we want to start from? I is equal to 0. So we want to start from I is equal to 0. Where do we want to go up to? We know that scores length is 4, right? Scores length is 4. So I want to not print 100 elements, right? I just want to print 4 elements. The 4 elements, if you look at this, is 1, 2, 3 and 4. And so I want to print until I has a value of 3. So when I has a value of 3, it's okay. But when I has a value of 4, I would want to stop printing. And that's the condition check. So I'll say I less than scores length. So while I is less than 4, so I is 0, less than 4, good. I is 1, less than 4, good, go ahead and print. I is 2, less than 4, go ahead and print. I is 3, okay, still fine, go ahead and print. I is 4, no, we don't have such element. So this is the right condition for that. So when I is 4, then this condition will be false. So in that kind of situation, we would go out of the loop. So that's perfect. The next thing is we want initially I to be 0, next I to be 1, next I to be 2, next I to be 3. How do we achieve that? Is by using I is equal to I plus 1, or the short form for it is I plus 2. I want to print the value of I. So I want to print percentage %d, comma. What is the value that I want to print? I want to print scores, and I would want to print the value inside. I want to print scores of I. Let's run this program to you. There you see all the elements of the array printed in here. So what we did in here is basically we created a variable called I. This I which we are using in here is called loop variable. So I would want to use the I from 0 to 3. So I would want to run this statement once with scores of 0, next with scores of 1, next with scores of 3, so next with scores of 2, and then scores of 3, and that's all. So that's basically what I would want to start with is I is equal to 0. The initialization is done only once in a for loop. So when this loop starts, this initialization statement gets executed. Next is the condition. Condition is basically, it says when the loop would end. So if this condition is satisfied, then it keeps running. As long as this condition is satisfied, it keeps moving around the loop. So it will continue doing the loop. And this is the increment which is done after the execution of the loop. So once it prints scores of 0. So what would happen? I would have initially, first when this for loop is first time executed, I has a value of 0. So the condition is checked. I less than scores length, which is 4. So 0 is less than 4? Yes, it is. So let's go ahead and say scores of 0 and 106 would be printed. Next, again it goes to the for loop, but now the initialization will not happen. Initialization will only happen once. So now I has a value. What is the value of I that we had earlier? I had a value of 0. What would happen is the second time it comes to the for loop, the initialization does not happen, but what happens is the increment. So I, instead of 0, it becomes 1. Then the condition check happens. I is less than scores length. Is that right? Scores length is 4. So 1 is less than 4. Yes, it's still true. So it prints scores of I, which is scores of 1, which is 15. So it prints this out. And then again it goes in, and this is the third time. So again increment would happen, not the initialization. Initialization would only happen the first time. All the subsequent times increments would happen. So I is 1, I becomes 2, scores of 2 is printed, which is 145. Then again it goes in, does the increment, I becomes 3, goes into the body of the loop, scores of 3 is 23, it prints 23, goes in, again does the increment, I becomes 4, 4 is less than scores length, 4 is less than 4, that's not true. So it goes out of the loop and starts running if there is anything at line 23 or 24 or 25. So that's how a for loop works. So this is a very simple example of a for loop. We looked at how to write the loop using a for loop. So the great thing about the for loop is now if I increment, like let's add so many values to the array, all that I need to do now is I can say scores length is equal to however 1, 2, 3, 4, 5, 6, 7. So I put 7 and it would print 7 values. So it becomes very easy to change your program. So it directly prints 7 values to the output. So it with arrays, if you have multiple values, processing becomes very easier. So I don't really have to do copy paste the same code over again to do the same operation again and again. Now let's move to another loop which is called a while loop. What I'll do now is I'll use a while loop. The syntax of while loop is very simple. While condition keep executing. Like a for loop, a while does not have an initialization or an increment. All that it has is a condition. So I'll copy the condition over. The condition is the same. So while this condition is true. So while this condition is true, I have to do the initialization, right? Where do we do the initialization in a while? You have to do the initialization before. So initialization should be happening before the while, and now I want to do the increment as well, right? I mean, without the increment, it would not work. So where do I do the increment? The increment is done inside the while at the end of the while. When I take a for, this is the easiest way you can convert it into a while loop. And now I'll take the body of the for loop and I would put it in the while loop. So there you see how we kind of copied over all the code in a for loop and kind of executed it in a while loop. That's it. If I run this program now, you'd be able to successfully have your first while loop running down here. That's, you can see that everything is printed. This is a very simple while loop. Okay, now you would have a question, right? I mean, I can do the same thing with a for loop and a while loop. Why should I use a while loop and when should I use a for loop? That's kind of the basic question, right? Okay, before that, let's reiterate the syntax of while. The syntax of while is very simple. While condition, open brace, close brace. That's it. And what would happen when we execute this is I is initialized to 0. So while I less than scores length, so I is 0, scores length is 7. So that's good. So it prints the value of I is 0, right? When it starts off, when it comes here for the first time, I will have a value of 0. So scores of 0 is printed, 15. Next, I plus plus happens, I becomes 1. 1 is less than scores of length. Yes, it is. 1 is less than 7. So it prints the first element. And so on, second, third, fourth, fifth. And when I becomes 6, it prints score of 6, which is the last element in the array, which is the seventh element in the array. And I plus plus, I becomes 7. And I is less than scores length, 7 is less than scores length. No, 7 is not less than 7. 7 is equal to 7 but not less than 7. So that condition breaks and the code comes out of the while loop. And if there was some code in line 16, 17, that code would have been executed. This is how a while loop runs. Now, when to use a while loop? The full situation we are talking about right now, in this kind of situation, it's easier, it's better to use a for loop, because rather than have this kind of a complex thing, I can do the same thing in for loop in a simple way. The way we would usually format things would be I is equal to 0, I less than scores length, I plus plus, and now within the braces I can write this particular thing. So in these kind of situations where I know how many times I would need to run ahead of time, so ahead of time I know I have to run it 7 times or 6 times or 5 times, whatever it is. In those kind of situations, it's better to go for a for loop rather than going for a while loop. But there would be situations where I don't know how many times I have to execute something. So let's say I'm reading something from a file, and as long as I have records in the file, I want to keep reading it. In those kind of situations, I don't know how many times I have to read ahead of time. So in that kind of situation, we say while there are more records, keep trying to read. So in those kind of situations, it's better to use a while. Now let's see how to do the same thing with a do while loop. Actually, do while is very similar to a while, except that the condition check, instead of being done at the start, is done at the end. So I'm moving the while to the end and I'll say do while, and I'll put a semicolon at the end of the whole thing. I'll do a run as local application. Aha, there you go. The entire array is printed. So the do while and the while, the only difference between them is the fact that in a do while, the condition check is at the end of the execution of the loop, whereas in a while, the condition check is at the start of the loop. What difference does it make? The most prominent difference that this makes is the fact that a do while would be executed at least once. Because I don't do a condition check here, this would be executed at least once. Let's consider a situation when there are no elements in the array and I'm using a do while. So if I has a value of 0, what would happen? It would execute the loop at least once. Oops, actually I have made a mistake. So scores length now is 0, right? There are no elements in the array. So I run this now. What would happen? It prints one element to the output, because what happens is it comes to do, it tries and prints the value at 0. It, even before doing a condition check, it prints the value, and only then the condition check happens. So in case of a 0 element array, the program will not work. But whereas if I was using a while loop. So I'm changing this and I'm putting a while loop. The condition check is at the start. So in this kind of situation, you would see that there is nothing in the output because the condition check happens first and it sees that there are no elements in the array, so nothing is printed. You would go for a do while loop when you would want the code inside to be executed at least once. If we use a while, there's a chance that if the conditions don't meet, then that particular code inside the while will not be executed even once. So when you want to be certain that it's executed at least once, in those kind of situations, you go for a do while. Actually, we are going to discuss loops in great detail further down in the programs that we would write. And I hope you would be able to get a very good understanding of loops in those sections as well. Until now, we looked at loops. We understood how to use a for loop, while loop, do while loop to print the content of an array. Now, we will focus a little bit more on functions. We will specifically focus on passing parameters to a function. I mean, what are arguments of a function and how do we pass values to them? That is the focus for this section. Now, we have a small program to print the scores. Let's say there was another scores array in here. Let's say the first array contains scores of team 1. Let's say these are scores for team 1 and these are scores for team 2. And let's say, yeah, obviously the scores would be different. Let's just make them different. Probably one of them is the same. So these are the scores that the team 1 scored. These are the scores team 2 scored. Now I want to print those values. The problem is if I want to print the values, the logic, I have to repeat it again. So I have to, let's for now assume that both the arrays have the same length. So team 2. So I have to copy the code over and now I would be able to print the scores of both the teams. But this logic of looping over the array and trying to print the scores is repeated. And that's what we try and avoid when we use functions. So let's keep it simple for now. Let's not worry about the complexities of having the second team. Let's start with creating a function. So what I'll do for a start is just create one small function. As we looked at earlier, the way we create a function is we start with return type. So return type, I don't want to return anything. I want to print the content of this course. So it's void. Void means a function does not return anything back. And next goes the name of the function. The name of the function I want to do, what do I want to do in the function? I want to print the content of the array. So I'll say print array. I could make it more descriptive saying print array to console or something of that kind, but yeah, let's keep it simple for now. And now I want to do all this stuff in the print array function. Okay, there are a few things that we'll discuss. For now, let's just do this. So I moved all the logic which was there in main to the print array function. It's good practice to have return 0 everywhere. If you saw a few of the example programs earlier not having return 0, always return something back to the to wherever your program is run from. 0 in case of success, and probably you can define other values as well. But that's okay. That's got nothing to do with the specific discussion that we are having right now. Print array. So now I moved the logic to print array. In main, I'm just doing a return 0. Will print array be executed? Will it get executed? Think again. As we discussed over last few videos, only main function is executed and whatever is called from the main function. So if I don't call the print array from the main function, nope, it will never be run. So now I'll do a print array. So that's good. So now I can do a right click, run as local C++ application. Okay, there you go. Print array is done and I see the content of the array in there. That's a good start. However, if I want to print the content scores for team 2, I have to again duplicate the logic. So it didn't really solve my problem, but at least now I've moved some of the code to a function. So what I want to be able to do for nav is I would want to be able to pass this score length from main. So instead of score length being here, I would want to be able to pass the score length to main. So I would want to be able to say print array and pass this course length in here. So this is called passing arguments. We saw how we pass arguments to printf earlier. So similar to that, I want to do print array course length. So how big is this course array? I want to control from main for a start. So I'm giving course length, and what should I do to make it have something in here? That's where the magic of arguments come into picture. So what is the type of course length? It's int. So I can say int course length in here. What happens in that situation is whatever course length I'm passing from main is passed as an argument. So this is called an argument. Here it's called a parameter. Here it's an argument. Return type, name, arguments. When we call the function, we pass the parameters. So we pass the parameters and get it in argument. But actually, all this nomenclature you don't really need to care about. So whether it's called parameter arguments, doesn't really make sense. But what you need to understand is the fact that whatever course length is here, it gets passed to this function, and you can almost use it like a local variable in here. That's the most important part. And now this 4, if I change to 5 and run it, this is just to show that this is being controlled from here. So you would see that it prints the 5th value as some garbage value, whatever was in the next memory location. 0 comes here, but it doesn't necessarily have to be 0. It could have been anything else. So if I put 15 in here, you'd see that there would be a list of 15 values printed in here. So you can see the values at the end are not really controlled by us at all. So the good thing now is we have passed the length of the array as an argument from here. To really make use of this function, I would want to also pass the actual content of the array using an argument as well. So I would want to move this out as well to main. So I'll do that here. I'll put the original length back, which is 4. So now we have 4 elements in the array. Length is 4. That's perfect. But yeah, scores team here, scores team 1 is not really defined. So what I'll do is I will need to pass the scores team 1 to the print array. But does print array, did we declare a second argument? Not yet. So let's go ahead and do that. What is the type of scores team? It's an integer array. The way we can define it is something of this kind. So int and scores. This says scores is an array. Scores is an integer array, and I want to pass scores integer array to this particular function print array, and that's how we do it. Now let's use the scores instead of the scores team. I called it scores instead of scores team 1 because really here it doesn't have to be the scores of team 1. We could eventually use this function to print the content, print the scores for team 2 as well. So in general, any scores can be printed, so I just changed it to int scores. My IDE complains about the brackets being in the wrong position. I'm putting them after the name of the variable. So we called it scores, and I put the brackets at the end of. Let's go ahead and run this program. Right click, run as local C++ application as usual, and there you go. There you see some output, 10, 101, 25 and 47 being printed. That's basically the content we had in the main. So the great thing about this particular program, now I can use the same program to print another array as well. The same function. So I want to print the marks of team 2. So let's say 101 and 100, 5 and 7. This is the opposition team. I don't want them to make a lot of runs. 101. Too much. Okay, let's use this. So now the great thing is I can actually use the print array function to print the scores of Team 2 as well. So now let's go ahead and run this. Run as local application. There you go. It's printing the values of both the things, uh, like 10, 101, 25, 47, and 10, 100, 5, 7. I could have made it very easy by actually making a printf. I'll just print a /n at the end of the print array, so that after every team it would print. There you go. So it prints a new line, and you see that we are able to print now the arrays by just calling it in this way. So as you can see here, it's very easy now, and that's the reason why it is recommended to use functions to do a lot of things. So if you see something that you keep doing repeatedly, then try and create a function for it. Try and think what would be the right parameters for it, and try and make it a function. Now let's look at little bit at making our print array function a little more better. One thing I don't like the fact is that I have the length first and the scores next. So I'll change that out. Int scores. Actually, it could print the name of the variable. I don't like it to be scores length. I'll just make it simpler. So I'll call it length. And now I can change. I can pass this, make the change same change, reverse the order of parameters, because I have to first pass in the array and then the length of the array. So also the other thing is, now this print array function not only on scores, you can pass any array to it and print the content of it. So I'll not call it scores, I'll call it ARR, or you can even call it array, and there you go. Nothing changes in the output. So now I can print any array, not just the scores, but any array I can print by using this particular function. And that's the beauty of writing functions, really good functions, because now this is reusable. I can use it in any situation where I want to print the content of an array to the console. If you are preparing for C interview, we have a complete C interview guide available. And if you are preparing for a C aptitude test, then we have C puzzles for interview as well. You can find the links to this in the description of this video. If you love this video, then we are sure you'd love our other courses as well. We have more than 10 GitHub repositories with examples on C, Spring, Java, basic web application, Maven, Mockito. Whenever you are in need for examples, you can look these up. We have a number of courses created on ChalkStreet as well. You can search for in 28 minutes in chalkstreet.com, and there you go. Right now we have 3 different courses in here. I'm sure there will be a lot more courses and we have a lot of courses on C, Java, Spring, and a lot of Java related frameworks and web applications on Udemy as well. You might like some of the most watched videos on our YouTube channel. We have courses on design patterns, web applications, Maven, Spring, Eclipse, and web applications as well. Good luck with your learning. All the best for you. Until next time.